Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video shows how using the idea of complements can help us find probabilities. Let's get started. First, we need to understand what complements are. So, the complement of event A, which we denote with A with a bar over it, so this would be A bar, but usually when we read it with respect to probabilities, we're going to say it's not A. So the complement of event A, denoted by not A, consists of all outcomes in which event A does not occur. So if, for example, event A represents all sunny days, then event not A is going to be all the days that aren't sunny. If event A means rolling snake eyes, and snake eyes is just you got two dice, you roll them, and they each come out to be 1, then event not A is going to be all the other rolls of the dice that you could make. So you've got everything, which is 100%, and then you've got A, which is a part of that, and then everything that's not A is the part that's not A. We can use this idea of complements to calculate probabilities. So let's look at an example to illustrate. Suppose we survey 2,234 U.S. adults and find that 242 of them are smokers. We can calculate the probability of being a smoker. We do that by taking the part over the whole, which you see here. So the part 242, that's the part that's smokers, the total 2234, divided out, we get 10.8%. We can also directly calculate the probability of being a non-smoker by using the same technique. So the probability of being a non-smoker, again, the part over the whole, we're going to take, to get the part, we're going to take that 242, which are smokers, subtract it from the whole to get the quantity that's the non-smokers. So when we do that, 1992 is our part, divide by the whole, 2234, and we get 89.2%. But that's not the only way to get that number. Okay, we can also calculate the same probability by using this idea of complements. So to do that, we recognize that everything is 100%, which is 1. And then if we subtract out the probability of being a smoker from everything, what's left has to be the probability of being a non-smoker. So when we do that, we get the same 89.2% that we got previously. Note the convention that's in use here when we're reporting probabilities. So in decimal form, we're using 3 decimal places, but when we're reporting it as percentages, then we're only using 1 decimal place. Those conventions are pretty standard. Now, if we want to know if an event has an unusually low or high number of outcomes, we just compare it with what's expected to be seen, and then if the number is far less or greater than that expectation, then we can say, yeah, we got something that's unusually low. Let's run through some sample questions to test our knowledge of what we just learned about complementary properties. So first up, if A denotes a simple event, what does A bar denote? Go ahead, stop the video, make your selection, and then come back and we'll see how you chose. Okay, I hope the answer you chose was answer option A, because that's the correct answer. It's not going to be B because, not A is not always unusual. Sometimes it is, but not always. Answer option C, events A and not A don't share anything in common. Okay, how can you be something and not be something at the same time? That doesn't make any sense. So C can't be right. Answer option D, again, you're not going to be sharing any of the outcomes because you can't be something and not be something at the same time. So D's not going to be right, which leaves us with answer option A. Now, if the probability of A is 0.027, what's the value for the probability of not A? Again, feel free to stop the video, run your calculation, come back, we'll see how you did. Okay, let's see how you did. So the probability of not A, we're going to use this idea of complements to get that. So if A is 0.027, we just subtract that from everything, which is 100% or 1, and that gives us the probability of everything that's not A. In this case, 97.3%. So is this value of P, the probability of A occurring, equal 0.027, is that unusual? Again, feel free to stop the video, come back, we'll see how you did. Okay, here in this case, it is going to be unusual because the probability that we're looking at is less than 5%. We don't have an expected value to compare with. And when you don't have, an expected value or one that's given to you, typically the value that's chosen as a threshold is 5%. And so, yeah, 2.7% is a little bit lower than 5%. So yeah, we're going to say that's going to be an unusual value. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.